So we've been saying now for a little while that pH is an inverse logarithmic scale that measures the hydrogen ion concentration. And we can also write this as a mathematical equation. pH is an inverse logarithmic scale of the concentration of hydrogen ions. So we can have math give us the same thing we've been saying in words. And once it's in equation form, we can use it to solve for the concentration of hydrogen ions if given pH, or we can rearrange this equation. Logs are based on the base 10. If we put 10 to each of these as a base, the log will cancel out. We can move the inverse over to the pH side, and just a rearrangement of this same information is 10 to the inverse pH then equals the concentration of hydrogen ions. So if given the concentration, if given the pH, we can easily solve for the concentration of hydrogen ions in a solution. You don't need to memorize these equations. They'll be given to you in high school, and you just need to understand what it is they're saying. They're saying the same thing we've been saying all along, but now we can use them to actually solve for quantitatively the hydrogen ion concentration. So let's think about that stomach acid again with its pH of 2. How concentrated are hydrogen ions in a solution with a pH of 2? So we've been given pH, we know that's 2. We are trying to find hydrogen ion concentration. So we'll use the second arrangement of the equation. We'll plug in the 2 for the pH, and then we'll enter this into our calculator, and I'll show you how to do that in a second, to get the answer, which is 0.01 molarity, or moles of hydrogen ions per liter. I'll put this on my MCPS so you have time to interact with it. But basically, if you turn your calculator side or your phone sideways in calculator mode, you'll get the scientific calculator, which is what you need if you want to be working with exponents. And in this case, we do. 2 ways I figured out to do it. If you can figure out a third, let me know so I can write that down. First way, you could use the 10 to the x power key, and in this case, we'd be using the inverse of 2 for our pH. That'll give you the answer. You can also use the x to the y power, and then you just enter your 10 and your 2, and that'll give you the same answer as well. All right, let's see if we can use it to solve the other way. If given the hydrogen ion concentration, can we find pH? And so in this case, we will use the first equation, that the pH equals the inverse log of the hydrogen ion concentration. So again, we're going to use your phone calculator if that works for you. Turn it sideways, and then the first thing you want to do is enter the hydrogen ion concentration. In this case, it's 0.001. Then you're going to press that log 10 button. Now, logarithmic is a base 10, so it may only say log depending on what kind of phone you have. Press that, and then you want to find the inverse of that. So you'll hit this to give you that. You should get an answer of 3. Does that make sense? Well, it's 10 times smaller than the concentration of hydrogen ions in the pH of 2 that we just solved for, right? It's 10 times smaller. That makes sense because a pH of 3 should be 10 times less acidic, or 10 times fewer hydrogen ions than a pH of 2. Still acidic, but again, we're talking about a small concentration of hydrogen ions. Okay, as always, please let me know if you have any questions on the practice. You should be good to go now.